Welcome back to the workshop and welcome to another episode in this electronic lead screw build project. Now this is the Clough42 electronic lead screw kit that he developed, and by kit I mean, you know, there's the main parts and the code and the microprocessor and all the hard work's done. You still got to adapt it to your machine, and that's what we've been doing mainly in this video series. So previously I've got the display mounted and the control panel there, we've got the encoder mounted, that's all nicely wired in now, comes off the spindle 1-to-1. And then just after the last episode, I didn't film this, but basically I've got all the GX16 connectors wired up, or quite a few of them anyway. So that one's for the encoder, it comes from here. That one's for the emergency stop, we'll talk a bit more about that in a minute. And then that one comes from the display. I've also got the power cable coming round that's looped around the back. So we've got all the wiring done except for the servo motor. So talking about the emergency stop, I had a lot of comments in the last video about concerns, ways it could be implemented and so on, which was really helpful because I put a lot of thought into it, and it kind of bothered me that what it implemented perhaps wasn't the best. So just to explain, this is the start stop for the lathe, and then the normal emergency stop is up here. And of course if you're over here and there's something wailing around, you've got to come past it and hit the emergency stop, which, you know, since I've owned it really, that's always bothered me. And I did have a comment about someone had a cut themselves on some of the swarf that was flying past as they went for the emergency stop. So thank you for that comment. Yeah, I mean it's all interesting stuff, isn't it? It's how should you do it? How should you make that emergency stop work? So originally I was planning that this emergency stop, all it would do is interrupt the 5-volt supply to the spindle. So if the lead screw was moving along like this and you were cutting a thread or something and it was going to hit the chuck or some problem, yes, obviously you can disengage the half nut, but maybe, you know, you could also do that. But yeah, it wouldn't stop the spindle, but it would stop the feed. And I was kind of thinking about the best way to do this, and I think I have a plan. Okay, this is quite a simple emergency stop. You've got a common in the middle, normally open and normally closed, and obviously you'd use common and normally closed, and when you push that, it breaks the circuit, cuts the power in this case. I did have a look round for, and they were a little bit harder to find because, you know, normally you want normally open and normally closed so you can check which state it's in. But I found one that was a dual pole single throw, so it had, and they were both normally closed, so it had two contacts, or two pairs of contacts, but they were both normally closed, and it's a 22mm one. So I'll take this out, open this up to 22mm. When it arrives, I'll show you a little bit more about how it works, but essentially I'm going to use one of those circuits to interrupt the 5 volts that goes to the board, so the microprocessor will just stop and it will stop feeding, and then the other pair of contacts will come from one of the interrupts on the e-stop system here. So those of you who've been watching this series might remember that I did have a lockout on the cover that goes here, and I took that off and I didn't really have any use for that switch, so I basically just shorted that together, and that is inside there. The only thing is, at the time I did cut those leads short, so I'm going to have to extend them. So there'll be a part of the e-stop circuit, the 240 volts one, will come to the front, go through one of those pairs, and then if you hit emergency stop, it'll stop the 5 volts to the spindle, and that will stop it advancing, and it'll also interrupt the 5 volts to the contactor, which goes to the motor, so the spindle will stop as well. So one switch, everything stops, which I feel a lot happy about. So that's the plan, just need to wait for that to arrive. Okay, so as I showed you a minute ago, I've got some of the wiring done there, but what I've also done, if you look up here, is taken the box off the wall, and it's over on the bench, and I've been doing some modifications. Let me show you. So the first thing you'll notice is that filter system that I mentioned in the last video. So it finally arrived. The line comes in this end, and then the load goes that end, so you've just got live, earth and neutral on either end, and then you've got a series of look like inductors and capacitors in there. Essentially a low pass filter to try and filter out some of the noise that was coming from the inverter from the lathe, and it was making its way through the mains, I suspect, and through into probably the microprocessor, and it was causing the display to jitter. You know, you don't really want that because it might be messing up your thread. So I don't know, this is a hi-fi grade one, so hopefully that's quite good. It's pretty big, so maybe better than those little metal ones you get in the inline ones in the IEC connectors, but yeah, I've never used it before. We'll see how we get on. So I've got my mains terminals connected up, and they come off the IEC connector. I've also got see the power down there. We've got the backboard down there earthed as well, and then there's another earth cable that comes off the main star earth down there. So all the earths are connected together. I've got this little flying lead up here, which will go up to the door. So that earth's off the main case as well, so the door's safe. And then you can see all the rest of the terminals all being connected as well. And then here on the e-stop, essentially that goes from the 5-volt power supply. So it goes from here through the e-stop system to the front of the machine, through a pair of one of the contacts, and then it comes all the way back and it goes to the fuse. So if you hit the e-stop, it interrupts that 5-volt supply, which stops the power going to the board and should stop it putting out steps as well. We'll just switch it off completely. And so I think that's mostly it. So I will get the door on and work out how much of this I need, get that hooked up to the door. We can get our finishing piece back on there. And then I think, oh yeah, I was going to put a few labels here and there, but basically it'll be ready to go on the wall. So let me get that done and then I'll see you over at the machine. Okay, I think we can finally connect these. So this one is the emergency stop. And then that one's the encoder. And then that one, the 5-pin, is the display. So I think I mentioned it in an earlier video. I've made sure the pin count in each one is unique. So that's 3, that's 5. I think that one's 6. And then maybe 4. I can't quite remember what the others are, but they're all unique. All right, so that's the display. So you can't get them in the wrong connector. All right, so these two, yeah, okay, so that's for the servo signals. In fact, let's have a look how many pins did it go for that one. 1, 2, 3, 4, so that one's 6. Ah, and that one's 2. So that's the servo power. All right. So I think, speaking of servo power, let's have a look at the options and see what we're going to do about mounting the servo onto the lathe. So essentially what I've got to do is get the servo motor down here and then this drive pulley mounted so that the servo can drive the pulley that we mounted on there, which is the lead screw, and that'll drive the carriage along. So need some kind of bracket that'll hold that in place and allow me to adjust the tension on this belt. And then I think we'll orient the motor that way so the cables can run down the side and then come up that cable chain and not get caught in the belt. Right, let's see what ideas we've got. Let's see how we're going to go about doing this. So I think a lot of people use, well, a lot of designs I've seen like this, they use a clamp like this or reuse this. I know James had his turned around and sticking out the front for about a year. So I'm quite tempted to take this off, measure it all up and basically make a clamp and then modify the end of it. So start with this sort of feature on it and then modify it so I can mount the servo on it. So let's go and have a think about how we're going to do that. So I've taken some ideas from other people who've made something similar. So thank you for your help and your suggestions, and I'm going to make something a bit like this. So it will clamp onto there a little bit like the original banjo did, which you put the change gears into. So we'll basically remake that in, I think I'm going to use 12mm aluminium plate. We'll use a clamp system, a little M8 bolt to sort of clamp it onto there. And that's the fixed part that goes back to the lathe, and then this is the part that needs to turn. So this will have the large pulley on it. And then over here, I'll run it off at an angle. There will be some standoff posts there and the servo will fit on there, and that'll have the small pulley on there, and then the belt will go between the two. That hole there is just a bit of clearance for the shaft that goes through the servo, just in case, just giving a little bit of space. And then these are slotted to allow me to adjust the tension on the belt. So I did think about picking up off this fixing as well, but I don't think it'll need it. I think once it's clamped on there, I don't think it's going anywhere. And then the wires from that, so we've got power, and the signal wires can come alongside here and then up into the trunking and be nowhere near the belt. So that's the plan. So I've got some material and the plans over on the desk over there on the workbench, so let's head over that way. So this is the paper template I just showed you over there near the lathe, and this is a bit of stock I've ordered in. I thought if you're going to order it and pay a bit of postage, you may as well order a little bit more, so we've easily got enough there to machine that out, and then we can use this for something else. So it's pretty thick. I think it's 12mm is what I called for on the drawing. Yep. Okay, so we'll get that out of there. I've also checked it, and it's unlike some stock I've had in the past. Yeah, I took a bit of a chance on this, a bit of an eBay special. Yeah, it's okay. It's plenty flat enough for what I need. I did try and look into ordering something that's a little bit oversized and then machine it back down, but in the 5 minutes I had to find this on eBay, so to make sure it arrived today and I can get on with it. They only had 12mm, so I thought I'd take a chance, but yeah, that's worked out okay. And then over here you can see what the drawing for it. So you can see roughly what it's going to look like on the isometric view there. So we've got our clamp system there, the M8 pinch bolt, which you can see in the section view there. So we'll have clearance and then thread on the other part. The other thing you can see is those reliefs there. So the servo motor will come in from this side on some standoffs. I'll turn on the lathe, and that will give me space to put the belt in between. And then back here I'll have some nut plates, basically almost as long as that, and fill in that rectangle, and they'll be threaded, and that'll make assembly a lot easier. You won't have to get a spanner down the back here to try and do it up, so that'll keep that in place, and you can adjust it nicely. Some of the other features we've got on here then, that's obviously sized to fit onto the lathe. There's our pinch arrangement there, our cutout. The rest of these radiuses and rough sizes are mainly just a bit cosmetic really, just make it nice and simple. So the main feature are the slotted holes, and then this pocket here that allows me to put a kind of nut plate on the back there. So there'll be two of those. I think that's really about it. And I think, as I mentioned before, the shaft of the stepper might stick into this plate a bit, so that gives it plenty of room to move about when you're making adjustments, because it's quite long on the end of the servo. So I think that's about it. So let's get the stock set up on the CNC machine and we'll get cutting. Okay, so we're all set up on the CNC machine. I've just zeroed the machine and found the zero on the edge of the part. We've got the compressor fired up, ready to go. Yeah, let's get going. And after a bit of cleanup, we've got that. So we've got the outlines cut, we've got the slots, clearance hole, and then our little pockets there with the nut plate to go in. And that's the clamp bit that will go around the main piece on the lathe where the lead screw is. So obviously we've still got to put the bolt through there, the clearance and the tapped hole, and then at the other end here's a little M5 tapped hole as well, just down there, which will hold or guide. There'll be a clip there that will hold the wiring as it comes around from the motor and sends it up out the way back to the enclosure. Right, so I think the next thing we'll do, we'll get this drilled and tapped for the clamp. I'll see you over on the drill press. So regular viewers might notice that actually that sounded an awful lot better than it has done in previous episodes when I was doing the cutting, and that's because I had a look at the spindle, and the little screws that hold this ring on the end here is usually where it would come loose. You know, every few months that would come loose and I'll tighten those up, and that was tight. So I assumed, because there was still some free play in here, then maybe it was the bearings that were on the way out. But I had another look recently, and it's actually the screws, this time it was the screws that held this piece onto there, and I tightened those up, and yeah, it's cutting really well, makes a nice sound now. And now I've got the mist system on, I'll just put it up out of the way, just make sure it definitely doesn't drip, because I'm not going to use it for a little while now. Yeah, it's cutting an awful lot better. So bad news for those of you who are hoping to see some kind of mega spindle upgrade project, but just knocks it down the list a bit, that's all. Never say never, but it's not going to be quite as soon as I thought I needed anyway. Right, let's get back to the bracket we're making for the servo, and I'll definitely see you at the drill press now. Okay, so we've got ourselves set up in the usual way. We've got the edge finder on there. We use the DRO to pick up off that edge, and then we'll use it to center there. Then I'll just check the drawing, and we need to make our holes through there. So I've got all the drills ready to go down here. So we've got our 3mm spotting drill there, so we'll mark the hole with that. Then we'll take it all the way through with a 6mm drill, and then we'll take it through with a tapping drill, that's 6.8 all the way through. And then we've got 8.5, which will be clearance at the top, and we'll just take that through the upper part. And then what we'll do, we'll bring it down so it just pokes through the gap there, and use the edge, the sort of angled edge there, just to put a light chamfer on the threaded part. And then we can run the tap down, and we'll put the tap fill the thread in the lower part there, and that should be it. Right, so let's pick up on our centres. Okay, next is the tapping size, which is 6.8. It's going to be an M8 tap. Let's go down again. Very handy, that feature. Now don't lose position. Okay, so we're just going to go through the top bit and then put a light chamfer on the lower hole there, and then that will become the thread. Slow it down slightly, here we go. Okay, so ready to tap that thread now. So we've got the clearance at the top, and we're just going to put the thread into the bottom bit down there. And because this is sticking out of the vise here and I haven't got a machinist jack, well, even if I did, it's a bit awkward to get it in there because you've got this base in the way. I'll just take it nice and easy, just get the thread started, then we'll take it out, put it in the vise, and I'll finish that tap off by hand. Then we've also got to put the M5 tap in the bottom here that holds the cable on. I'll do that off camera, I'll just do that manually in the vise with the cordless. Right, let's get to it. Okay, let's get it started, so I'll just finish that off in the vise. And after all that, here it is finished up. So we've got our thread tapped in there for the pinch bolt, and then I drilled and tapped that for M5, that's for the wiring connector. So all we need to do now is make the little nut plates and the spade. Where did these come from? I made them while you were messing about at the lathe. Oh, alright, cheers. Thanks, man. Alright, no problem. Take it all back, is not so bad after all. I heard that. Well, I guess that means we can start putting it together and make sure it's all going to fit. So let's start with the bolts, I guess. Or screws, I guess, more correctly. So I think I showed this earlier in one of the earlier series, but this is the Ep07. This is the integrated servo motor. It's the same one that James Clough ultimately went for. You got all the specs on the side there. It's got little dip switches on the back there. and then you just got your power here, and then all your your different step and directions and the alarm as well. And then this one's just, I think this one's just for the programming to set it all up. Right, so this will go on, yeah, that way round. I guess we'll go put the belt on first, because it might get trapped. I'm not really mocking it up, but still. Spaces might be a good idea, so they go that way around, I think. The narrow ones go at the front, so to give you some clearance to the belt, and then the big ones at the back. While we're here, we'll put all of them in. Last one there. Actually, which side of the belt does it end up? I think it goes on the outside. That way, yeah. Started. Turn it over and do the other one. So this nut plate's a reasonably good fit in there, not super tight, so it allows it to slide backwards and forwards, but obviously it should allow you to just tighten them up from this side and not have to try and fish down the back and get a spanner in there. Obviously the spacers keep that the right distance apart, so we can level that up with the other one. And then I've relieved this here, so it should clear the belt. Knit those up. Still slide it. Yep. Tighten these a bit more. Slide it, there we go. Okay, let's go and offer it up to the lathe. Right, so it should fit over this piece, which is fixed to the lathe, and then the lead screw runs inside there. It's fair to say that's quite a nice fit on there. I won't nip it up yet because it will put a permanent set on there, or it might make it more tricky. Yeah, I think that's going to work. Now I think when I finally put this on for good, well, my plan was to put that on that side, so rotate it 90 degrees, and then the wires that come out of here can be directed away, otherwise they're going to have to come under this belt. So yeah, we'll do that. So yeah, I think that is going to work, because the pulley it goes onto is quite large, so that should miss there. Right, so I think we've got that bit working. So speaking of pulleys, let's go and see where we're at in terms of the big pulley that goes on the end of the lead screw here. So as you can see, I've got the pulley set up in the lathe. I've turned a 12mm mandrel, so it's a nice tight fit on this pulley that's got a 12mm bore. Now we need to open that up to 14mm and we need to put a keyway in. I was also thinking about maybe removing some of the material, so creating a bit of a pocket there and then machining these slots out here. Obviously we're doing that on the CNC machine, and then leave a bit of a bore in the middle here, mainly to make it lighter, or more importantly to reduce the inertia in this because it's quite heavy and it's going to take a little bit of motor power to spin it up. I'm not really sure if I definitely need to do that or not, and I'm kind of leaning towards just leaving it just for the effort involved. I'm thinking once the motor spins this up, you're not going to be in the cut at that point, and then it will go into the cut and this will be spinning, so it acts a bit like a flywheel, so it'll actually help if anything. So I'm leaning towards just leaving it stock as it is. While I ponder that anyway, I've got it set up here, and let me bring you in close and I'll explain what's going on. So I've got this DTI looking on the face there and looking at the run out this way, and then we've got this one here looking for the high spots on the teeth, and I'm expecting a bit of run out here, but let's just see what we got and we'll see what we've got on the face. So if we start on the face one, so spin it, you see it's actually quite good and it is actually engaged. So it's within about 0.02, 0.03 in kind of face run out like that. So yeah, pretty happy with that. But you'll watch this one down here. I'll set it up so that, as you can see, it's a 0 on tooth there, and as we go to the next one, 0, and eventually 0.05, 0.06, 7. I think it got to about 0.2. Here we go, 14, 15, 18, somewhere around there. It's coming back. Oh, there we go. Somewhere there. It's about the worst. Yeah, it's coming back again. So ideally I'd want to look in the valleys, I think, but assuming that the top of this tooth is relatively accurate, I guess that's where the belt's going to sit, so maybe that's the critical dimension. There's 0.2mm of run out, and I really wanted to get below about 0.05 really. I think that's too much. So the hole's not concentric enough with these teeth. So I think what I'm going to do is we'll take it out of here. I'll set it up in the forejaw. I've got a number of these little brass, round brass bars, and they just fit into there, and you can still get the jaw onto that. So I'll end up with 4 of those, and I can dial it in, and then I've got to try and dial it in so that this is running true. Obviously the bore will then be out, but I can then bore that out concentric and open it up to 14mm to get a nice fit. Then I've got a couple of choices on the keyway. I can either make a little custom tool, which I'm quite tempted to do, to actually just come in on the lathe and just keep going backwards and forwards with the carriage and nibbling a little keyway out. Or I could go to the effort of making a custom guide there, because I don't think I've got one for 14mm to put a 5mm keyway in. I've got a 5mm broach, I just don't have the broach carrier for 14mm hole. So got a couple of choices there, but we need to bore it out to 14, we need to put 5mm keyway in, so they're the next jobs. So we'll set this up in the forejaw and then we can get on with that. So if I can get that out again. So I think the video is getting a bit long, so I'll call it there. We'll put that footage into the next episode, and then we can finally get this servo installed, and then we'll do the wiring for that and get it kind of wired up and see if it works. The other thing we can get onto next time is, remember me talking about this emergency stop switch? So this at the moment just interrupts the 5V supply to the microprocessor. It doesn't stop the spindle, it's not a complete e-stop, which bothered me. So this has finally come in. So as you'll see, we got 2 or a pair of normally closed contacts on both sides, which is a bit unusual. So if you're going to go for this solution or something like this for your machine, just make sure you get the 2 normally closed, because then I can put the 5V in this side and that will switch off the microprocessor, and on the other side I can interrupt the safety system, so it will be like pressing the E switch on this. So those of you who watched a couple of videos back, you'll see that there was a pair of mains wires as part of the e-stop system that came out to a micro switch over here, so when you took the case off it stopped the machine. I cut those back and joined them together so that it kind of overrid that. I need to then, because I cut them short, I need to extend them and bring them forward. They'll go into here for the main side, and then the 5 volts that's already there will go into this side. So when you hit e-stop, the spindle will stop and the feed will stop from the microprocessor. I think that's okay to do that, to have mains one side and 5 volts the other. It does say up to 440 volts and 10 amps. So I assume that the insulation between each side is very good. I guess that's the separation. Hopefully there's nothing close inside. I think it looks like 2 physically separate switches, so I don't think there's any danger of the mains getting across to the 5 volts or arcing or anything like that, as far as I can see. So that's the plan. Obviously I'll have to open that out, but I'll feel a lot happier with that solution. A nice big e-stop switch. Everything's switched off when you do that. So if this project interests you and you want to follow along, then feel free to subscribe. As always, if you hit the bell, you'll get a notification when I upload the video for when I machine this and get the motor finally installed and the e-stop. And I think in that next video as well, we will try it, switch it on and see if it all works. So in the meantime, I hope you've enjoyed this episode, and thank you very much for watching, and see you next time.